Hey, grade 7, here's a little review, 3.4 to 3.6. Before we begin it, I just want to show you this excellent intro. Mad props to Alex. Quite possibly the worst recorder playing on the face of this earth. Oh no, here it goes again. Sorry about that. All right, so we're looking at volume and area. Imagine you are an evil scientist and you're designed. I asked to design we want to ask your henchman to design some evil robots. In particular, looking at designing this portion right here, which is like the body or the cavity of this beautiful robot. Problem is, you need a space right in the middle, and this, of course, is because I don't know. You got to shoot rockets through there. I have no idea, but you need a space that goes all the way through the body of the this evil robot. So you have to figure out how much metal do I need, and this is a surface area question. How much metal do I need to make this sort of metal box? Here's the dimensions that you're given. It is 12 centimeters long. These are all in centimeters. I'm just going to write it once, but we're going to assume they're all in centimeters. It is 8 centimeters high and it is 7 centimeters deep. The hole in the front and the hole in the back are the exact same, and they measure 4 centimeters by 5 centimeters, or 5 by 4. So we've got to figure out surface area. The thing is, we don't see all the sides. Like there's a side over there we don't see, there's the bottom that we don't see, and there's another side over there that we don't see. And what's the best way to see all the sides? You got it, it's the net. That's right, so we see this net over here. We're going to use this beautiful unpacking of this box over here to figure out the total surface area of this big sheet metal. We have some serious clues here. We have a box right there, and that looks suspiciously like that little hole right there. So we know that that is the front. And if this is the front, then obviously this is the back, because there's a hole that passes all the way through that joins them. So these are we have to label them. Remember that there are congruent sides. So we're just going to call this one right here A, and we know that this one is also A because it's the front and the back. So that's this one right here. This is our A, and then the one in the back is also the A. We'll just go down one more. We're going to call this one B. This would be the top of the box, which would be right here. It could also be the bottom of the box too. And we're also going to call this one the same. Those are going to be the same dimensions. The sides of the box, which is right over here, the sides that we cannot see, we're going to call those C because we can't see them. Awesome pun, I know. All right, so C is over there. So now we only have really 3 boxes times 2. We have one A, a B, and a C. And if we double them, then we've got the total surface area. And that now we're going to we're going to substitute some values. So 12 is the length right there, because we can see that right here. This is the length of the bottom. And if that one's 12, every single line that cuts across here and here, they're all 12, every single one of them. So you just have to take your handy dandy 12 and drop them all in there. Following that, let's look at some of the sides. The front of the box and the back of the box are 12 by 8. So we're going to grab an 8 and we're going to say that that is 8. Now this flap right here is going to join in with this piece right there. So these actually have to be the same. If you can picture a box that folds, they actually have to touch. Oops. I just cut down a couple 8s. So there's an 8 there. This is also an 8. This top piece, the top piece which is right up here, we already looked at that one right there, it's 12 along here, and then the other dimension is a 7 that way. So this is 12 by 7. That's a 7. That also tells us that the side piece is 7 by 8. This one we know obviously is an 8 by 12 because it's the same. It's an A. It's a match of that one. And then the other, 8 by 12. And then this one is the match of our B, so it's 7 by 12. If you take a look here, I forgot to put the box. I'm sorry, the box in the middle. Take a look at the box. Here's the length is 5 and the top is 4. Now we just have to put all these numbers together and to get the total surface area. We start off with the formula. The total area is the area of A here's A, plus the area of B, and plus the area of C. But we double it because we just find out the area of one of them, and then we double it. So I'll undo these beautiful letters here. So now we substitute. Once we've written our formula. We always write the formula. Then we substitute. The area of A is 8 times 12, and that 8 times 12 comes from this, 8 times 12. The area of B is 7 times 12. There's a 7 and there's a 12. So here's the width and there's the length. And finally, we have the area of C is 7 by 8, which is right here. 7 by 8. We calculate one piece at a time. We do 8 times 12, which is 96, 7 times 12, which is 84, and 7 times 8, which is 56. We add those three together, and we get a total of 236. Now we double it. And why do we double it? Because all we've done is calculate the area of one box, like 1 here, 2, and 3. But we have to actually double it because there's 6 sides to this thing. The total is 472 centimeters cubed, and it's cubed because this is a three-dimensional object, right? Now, bear in mind, there's this little trick here, though. There's this little box in the middle that we need to address. If we don't subtract this area right here, because it's a hole, there's actually a hole there, then we're at too much. So actually, the surface area is the total, which was 472, minus the area of the two boxes. So 2 times length times width. Each box is 4 times 5, and there's 2 of them, so it's 2 times 20, or 40. We take our 472, and we minus that, subtract 40, and we get 432 centimeters cubed. Boo, yeah.